Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through finding the equation of a line. So this is the opposite of what we did in the previous lesson, in which I gave you an equation, you turned it into a table of values and then a graph. Here, I'm going to give you the table of values or the graph, and you have to find the equation. So the equation of any line or linear function can be written in the form y equals something times x plus something. So y and x are variables, m and b are values or constants. So we're actually going to find the value of m and the value of b. That seems pretty logical because a line can be written in the form y equals mx plus b. All I need to do is find m and find b. So I told you in the last video what these actually meant. So m is actually the gradient. It's the amount by which y values increase or decrease each time x values go up by 1. And b is the y-intercept, which remember is the y value when x equals 0. Okay, it's where the line hits the y-axis. That's why it's called y-intercept. So let's first look at an example in which I'll give you a table of values and you will find the link between x and y. So let's look at the table of values that we have here. We have some x values and some y values. We want to find an equation that links the x values and the y values. We want to find an equation of the form y equals something with x's in it, so that I can get the y value if I know the x value. So we know that this is linear because each time x is increasing by 1, the same thing is happening to y each time it's going down by 4, okay? So it wouldn't be linear if it went down by 4 and then down by 3 or whatever. But because it's going down by 4 each time, it's linear. So that means it can be written in the form y equals something, m times x plus something. So remember, m, the thing that goes in the first box here, is the gradient. So that is the value by which y is increasing or decreasing each time. The thing that goes in the second box is the y-intercept. Okay, so I just have to follow these steps. Find the gradient, find the y-intercept, and I'm done. So because each time x is going up by 1, y is going down by 4, the gradient is minus 4. So I just put a minus 4 in the first box. So the y-intercept, y value when x is 0. So when x is 0, y is minus 4. So we can just put that in the second box. We're actually done. The equation linking x and y is y equals negative 4x minus 4. So what this is saying is to get the y value, you take the x value, times it by negative 4, and then subtract 4. So that's the only equation we can write that will link the x and y values. So it will work for all of these points. If you take a random point like this one here, if x equals 1, then y is minus 4 times 1 minus 4, which is minus 8. So I can get the y value when I know the x value. So that's how you do ones like that. So we're going to look at a table of values example now that's a little harder. So please pause and copy this down if you need. So what makes this example a little more difficult is that we don't have x going up by 1 each time, nor do we have the y value when x equals 0. We're still going to do it the same way. We're still going to have the equation y equals something times x plus something and fill in the two boxes. It's just that in this example, we'll have to do a little more work. So this time we have x going up by 2. Each time here x is going up by 2 and y is going up by 6. So this is still linear because each time x is going up by 2, y is doing the same thing. So the gradient in this case, if each time x goes up by 2, y goes up by 6, that means if x were to go up by 1, y would go up by half that, 6 over 2, which is 3. So y is going up by 3 each time. And that's in keeping with this result here. When went up by 5, y went up by 15. Because 15 over 5 is 3. So the gradient here is 3. If x were to go up by 1, y would go up by 3. So how do we find out the y value when x equals 0? We can add values to this table. So for example, if we were to increase x by 1, so it goes to minus 6, y would go up by 3, be here. So we can do that in this region here. So if x were minus 2, so if x goes up by 1, y would go up by 3, so it would be 5. If x were to go up again by 1, y would go up by 3, so it would now be 8. If x were to go up again by 1, it would now be 0, and y would go up by 3 again. So it would be positive 11. So we just follow the patterns. So because each time x goes up by 1, y goes up by 3, we figured out that when x is 0, y would have to be 11. So that number goes in the second box. So that is our equation. Y equals 3x plus 11. And that works with all the values here. If you times negative 7 by 3 and add 11, you get minus 10. If you times minus 5 by 3 and add 11, you get minus 4. Similarly, keep going. If you times 3 by 4 and add 11, you get 23. So that is our equation. So we're just going to do a couple of quick examples where you're given a graph and have to find the equation. So please pause and copy down if you need. So let's now try and find the equation of the line in green. So what we have here are 2 points that it goes through. So we know when x is 0, y equals minus 1. That's this point here. X is 0, y is minus 1. This point here has coordinates 1 for x and 2 for y. So we sort of have a mini table of values. So we can do the exact same thing we were doing. So the equation of the line will be y equals something times x plus something. First box is gradient, and the second box is the y-intercept, or the y value when x equals 0. So the y-intercept is actually really easy in this one. It's where it hits the y-axis. You can see it hits here at y is minus 1. When x is 0, y is minus 1. So you just put a minus 1 in there. So the gradient, what you can see here is that if x has gone up by 1, y has gone up by 3. So the gradient must be 3. We know this is a linear function because it's a straight line, the graph. So we know that each time x goes up by 1, y will do the same thing. So that is the equation of the line. Y equals 3x minus 1. That is the equation of the line in green. So now we're going to do one a little bit harder. Please make sure you pay attention to this one. So now we're going to look at the equation of the line in yellow. So you can see for this one, we again have a couple of points. So the first point on the left, x is minus 1, y is 2. And then the other one we have is x equals 2, y equals negative 1. So let's have a look at what the gradient and intercept would be. Because it's a line, because it's a linear function, it's going to be y equals something times x plus something. So again, we can see the y-intercept. Clearly, it goes through the point 1. 1 is where it hits the y-axis. So I'm going to put a 1 in that box. Now, what would the gradient be? So if you're stuck, use the formula. Gradient equals rise over run. Another way you can see it is it's the change in y values over the change in x values. We actually use that formula without knowing in the table of values. So remember what we said is, because if x is going up by 3, what's happening here is y is not going up by 3, but down by 3. So remember in the previous example, we just divided them. So y is going to be, so the gradient, is going to be the change in y divided by the change in x. That's what we did last time. So minus 3 over 3 is minus 1. So the line in yellow, it has equation y equals minus 1x. You don't need to write the 1, you just write minus x plus 1. okay? Or if you like, minus 1 times x plus 1, okay? So I just want you to note here, if the gradient, which is m, is negative, that means the line will lean to the left. See, the yellow one is leaning to the left, the green is leaning to the right. And that means that it's decreasing. That means when x increases, y decreases. The opposite is true. Positive gradient, as we saw in the green line, that leans to the right. See how the green line is leaning to the right? And that means that when x is increasing, y is also increasing. You can see that y went up when the gradient's positive, y goes down when the gradient's negative. All right, so hopefully you've learned something from this video. This has been the luckiest maths teacher in the world. Have a great day.